All right, here we are with Mike from Noyes Development. And Mike, could you introduce yourself?
All right, I'm Mike Frey with Noyes Development Company. Noyes Development's a local Portland area home builder, and we've been in business since about 1993. We're focused on building in the Bethany Cedar Mill area. It's kind of where we call home, and we build about 50 homes a year right here in the local kind of Bethany Cedar Mill market. And we focus on high-end spec homes, and we build high-performance homes. So a lot of our homes, almost all of our homes, are Zero Energy Ready certified by Earth Advantage, and all of them receive an Earth Advantage Platinum certification. So some of our priorities include making sure that what people see is what they expect, but we also want to make sure the things that they don't see are as impressive and well put together as the finishes that they can walk into any home and see. We believe that the things behind the walls matter actually more than the things that are finished in the end product. We've always been about building good homes. Through our continued study and evolution of what we do, we were able to take some of these green building practices and realize these aren't just for a select group of people who really care about the environment more than others or something. These practices that we put in place just are part of building better homes. We should be doing these things naturally anyway, and it's something that I think our customers are starting to see and other builders are seeing, that if we want to be proud of what we do, build something that's going to last, these are just common sense principles that we should be looking into and then using. For our customers, we see a lot of different approaches for why they choose what they choose. A lot of people are just initially shopping based on location, home size, schools, some of those things. So that's going to be a common factor that you're going to see anytime you're selling a home. Then showing them the difference that you can bring as a builder and that we bring as a builder is where it becomes really important. So we're able to highlight that we're going to be able to build them a home that's going to be more comfortable, a home that's going to be healthier, a home that's going to be more durable, because it's a huge investment. You want it to last. And a home that's going to save them money every month, and a home that they can feel proud of. So which ones of those reasons people latch onto the most can be different. I think we find a lot of people being really interested in health and comfort. Not surprising, right? Some people are going to focus in on the monthly savings. And then at the end of it, I think people just really do feel good knowing that they're a part of something that's more sustainable and it's better for our community and our world.
That's awesome. Yeah, I really like how you break that down. The old conversation was about energy efficiency and talking about the dollars and cents. And I really like to hear how it's transitioned into those health and comfort benefits and durability overall, right? And so that to me seems like it's a much more evolved and mature conversation around how these are just better buildings, which I think is what it sounds like this is all about, is just achieving a higher standard. And that's pretty awesome. And then with these particular homes, it sounds like a lot of them are going to be Zero Energy Ready, if not all of them.
We're building almost all of our homes to a Zero Energy Ready standard now. A few years back, we started to realize we're really close to meeting that standard just with what we were already doing. So we started to be a little more intentional in some of the planning that we put together. And we still have some challenges sometimes where we either have some beautiful trees that are providing a little too much shade for the house, or as we're trying to keep some architectural variety to the neighborhood, sometimes roof line doesn't quite maximize the solar potential that we have there. But almost all of our homes at this point are getting that Zero Energy Ready certification from Earth Advantage. We've been able to put solar panels on a couple of our model homes to just show people this is a zero energy home. We're standing in a zero energy home right now. And I think a lot of times people don't realize that something that they can have today in a kind of traditional neighborhood. It's been really enlightening for people to see an actual installation, and it's allowed us to drive more leads to our solar partner and actually getting panels on the homes for more zero energy homes, not just Zero Energy Ready here. All right, Stephen, so we're in one of our model homes here. Let's walk through and just check out some features and talk about the home.
Excellent.
We have some controls for our HVAC system. So we use Mitsubishi heat pumps in all of our homes. They're a variable speed, really high efficiency heat pump, and they can heat and cool the home year round, no matter the temperature. And we also have an alarm system that provides some different home automation options for people. This system can be used in conjunction with garage door openers, smart light switches, speakers, all kinds of different things. A few of the options that we include that can work with it are the garage door opener, the irrigation controls can actually be linked to it, and some of the lighting controls, their additional options can be. Next to it, we're going to actually transition to some more mechanical equipment like we talked about the thermostat here. This is just a nice little example that shows all the ductwork for the home is inside the conditioned space. It's running inside these floor systems, above us. And by having all that in here, we're producing greater efficiency and greater health for the home. And it's kind of amazing to think that we actually have a bridge above us, essentially. And even with this section here that you would think it'd be hard to get all the ductwork across, we're able to keep all the ductwork inside the conditioned space of the home. Now, if you can do it in a home like this, where you have a bridge as a pass-through, and it's not just a simple stacked two-story home, you can do it in any home.
Yeah, my understanding is you can lose about 30% of your home system's energy performance just by having leaky ducts that are outside of the building envelope in an attic or in a crawl space. And so what this does is it really creates a much tighter system, and if there's any leakage, it's to the inside conditioned space of the home.
Absolutely. So we seal all the ductwork, we size it, and we run specific calculations for every home to make sure that we're getting the right amount of airflow to every room. But if we do have a little loss in between, like you said, it's just all going to the home anyway. And this is one of the most critical steps to building a really efficient home and to meeting a zero energy ready standard.
So where are you putting the furnaces for this?
So we actually can go upstairs and take a look. Depending on the plan, we find different locations for them. A lot of our plans, we put the furnace in a closet in the laundry room. Right. Excuse me, the air handler, not the furnace.
So, Mike, my understanding is that you're using these advanced Mitsubishi heat pumps as essentially your new furnace. Can you talk a little bit more about that transition and more about the equipment?
Yeah, so as we transitioned into building zero energy ready homes and we realized that we were producing this standard, we kind of started to evaluate whether or not it made sense to have gas furnaces in our homes. If I was going to tell people that they could offset all of the energy use in their home, but then pay a gas bill, it just didn't feel like the right balance to me. So we started evaluating heat pump options. And now some people aren't familiar with heat pumps, but a heat pump can both heat the home in winter and cool the home in summer. So older heat pumps were not as efficient, couldn't operate in lower temperatures. Newer heat pump technologies can operate year-round. You can get down to even below zero temperatures with some of the units that are out there, or just very cold temperatures that we don't have to worry about in Portland. And they can efficiently heat the home. Then in the summer, they're actually more efficient than most air conditioners for cooling the home. So having that as an electric-based heat source and cooling source made a lot of sense when thinking about pairing things with solar. So we use these really high efficiency, variable speed Mitsubishi heat pumps. And they're very small and compact and quiet. We still run ductwork throughout the house, and we have an air handler that we locate inside the home that is essentially just a giant fan that is able to distribute that air to the home and the conditioned air to the home. So most of our homes, we locate this air handler inside a closet in the laundry room. Sometimes our plans have different locations for that. But we also put some insulation around that room and a solid door so that there's no noise concern from the air handler's big fan being inside the home. Additionally, because this is a variable speed unit, that means that the fan doesn't run in only one speed or only two speeds. It's able to cycle up and down, and the compressor is able to cycle up and down as needed. It's a lot quieter and it's a lot more efficient as a result.
Yeah, it's awesome. I think maybe some folks don't realize that a real basic heat pump that's been in their home for years is a refrigerator. And so one way to think about that is that, that refrigerant is being used to pull energy out of your food and milk and things like that, and then you're expelling that in the back of the refrigerator. So you feel like that hot side of the heat pump is the back, the refrigerator typically, and then the inside is kind of the cold side. And the cool thing about this Mitsubishi is what it sounds like. You have an outdoor compressor, and so then you've got an interior kind of condensing unit, so a bunch of coils in that air handler in there. And so in the summer, we're going to take the heat from the home, we're going to pump it out to that outdoor unit and expel it. And then in the winter, we're going to take the heat from the outside, even when it's kind of cold out, and we're going to find some of that heat, and we're going to bring that and pump it into the home. So that's kind of the essential of the heat pump. And my understanding with these Mitsubishis is that they're 11 HSPF. And so that kind of translates to real basic terms that you have essentially 1 kilowatt of energy in, and you're getting like 3.5 almost, between about 3.4 or so kilowatts of energy out of the system. And they're getting the rest of the energy from the air essentially, and the refrigerant cycle system. So I think that's also really important too. So if you've got somewhere in that 3.5 zone of kilowatt output for 1 kilowatt in, that sounds like 300% plus energy efficiency, right? That's pretty amazing.
Yeah, Stephen, that's a great explanation of the whole process. Buy one unit and get the benefit and production of 3.5 or so units of energy. It just makes a lot of sense.
And to be fair too, natural gas is quite a bit less expensive than electricity, and of course we lose a lot of electricity when we manufacture it with natural gas or other types of products at the plant. And so my understanding is that we lose somewhere in the realm of like 200% or so, 270. We have to get to the point we're essentially losing 70%. When you reverse that math, you need a heat pump that needs to be like 270% efficient or higher to be efficiency of 100%, let's say, natural gas. And when you're at 300%, you actually are.
Yeah, I think we're fortunate in the Pacific Northwest that we have a lot of clean energy being produced, but it's true that a lot of the electricity that we're buying is actually produced through natural gas use. But when we pair the electric heat source with solar panels on the roof, we can directly be sending the energy that we need from our roof to our equipment, and kind of cutting out the middleman, if you will, for so much of the year. And we are grid reliant. We're still connected to the power grid. But for a lot of the times during the day, the sun is shining. Even when it's cloudy, we get great solar production. And we're able to take that energy and just send it straight to the home for use.
So essentially, these developments are renewable energy providers. It's almost like this Noyes Development becomes a kind of micro renewable energy solar provider to the rest of the grid.
Absolutely. So through the net metering process with the utility companies, we're creating this energy on the homes. We're using some of it. A lot of it we're not using in real time in the moment. So we're just sending it right back to the utility companies as clean power. This clean energy is going right back to PG in our case. And then we're able to pretty much just put that in a bank account of power. And so all the energy that this home produces, if it's not using it, it's going into the bank account. And then when we get days that aren't as sunny or they're colder or we're using a little more energy, we can just draw from our bank account. And for a zero energy home, at the end of the year, all of that equals out to where you've put enough money into the bank or enough energy into the bank that as you draw it back out, you're equal at the end of the year.
So you're netting zero in that
Netting
case.
zero. Yeah.
Fantastic.
So here we have a central vac system. There's a hide hose. There's a concealed hose inside the wall here. And we have a little card that can show people. But one of the benefits to this is central vac. A typical vacuum kicks a lot of the stuff back out into the air as you vacuum. The central vac makes sure that everything goes out to a sealed container and is exhausted outside from the house. And this is super convenient because we have a hose that just extends from the wall and then will retract back in to be hidden and out of the way. So with kids in the house, this is really useful. because they can actually clean up their own messes, and knowing that the indoor air quality is improved from this is really an added benefit.
My understanding is that you rough-in those systems for all of your homes, and it's an option for your clients. Is that correct?
Yeah, thanks for clarifying that. So the actual finished system is an upgrade option. It's easy to add on after the fact, but we do the pre-plumb, which is the part you have a hard time going back and doing later. We do that standard in all homes.
So that's really, really excellent. Great. So we're here in the mechanical area, and we're looking at a 97% efficient gas hot water heater. It's made by Navian, and it's pretty awesome. It's condensing, and it's about as efficient as you can get for on-demand hot water with natural gas. And then over here, we've got this vacuum flow central vacuum system, and that's pretty awesome too, especially for indoor air quality. And the cool thing about it is usually when you vacuum a home, you've got that bag that's inside the vacuum that filters out the air that you're pulling from the carpet or the floor or whatever else. So as that air comes up into the bag, little bits of it get out. So little particulates and whatever else kind of suspend up into the air again. So you're kind of like recirculating dust into the air. Whereas a central vac has this motor vacuum outside, typically in a garage, or the space is loud, so want the sound to be outside of the main space. But we have this thing sucking air when you hook up your hose inside, and then it's going to blow that exhaust air outside. And so that fine particulate kind of leaves the house and then blows out into the outdoors, where it can kind of deal with that fine particulate through leaves and whatever else out there, and not through your lungs inside. So it's pretty awesome. All right, so this is a Solar Edge inverter. It's pretty awesome. So you're taking the direct current from the roof, the solar panels, and we're inverting that into alternating current. And then you can use it for really cool things like this car charger. So that's pretty sweet. And the Noyes has this option on all of their homes, which is pretty awesome. So they're rough and ready for all of this equipment. This is an example of when you actually do install the full equipment. And so being rough and ready for it all is kind of a solar, zero energy ready home. And so we're going to talk a lot about that. But yeah, in this particular case, we've got somewhere around 10 kilowatts of solar power up on the roof. And that should offset all of the electricity used on site in this home on an annual basis, if not even a little bit more. And provide that extra energy to really cool things like your sweet new Tesla. We have a couple excellent learning tools right in front of us right now, and one of them Noyes put together for us, and it shows all of these high performance details that you want to see in a zero ready or zero energy home. And so one of the ones I really want to point out, which I think is fantastic, is this raised heel truss detail. And so what you can see is you've got a good distance from the top of the roof to the top of the wall that we can fill with insulation. And there's a ventilation cavity that's able to fit in this top inch and a half or so. But here we've got a good 8 to 10, sometimes depending on the size of this raised heel, 12 to 18 inches even, of insulation value. If we look at the typical newer home model, which we also have right here, you'll see what usually happens. You get this compression where you don't have any insulation down at this edge, and so that ventilation cavity that's required comes down and your insulation essentially goes to zero. And so that may not seem very significant, but when you remove all of that extra insulation from that heel of the truss, from around the roof of a home, that whole perimeter, you can take that insulation value down 30%. So everyone's like, oh, I've got R38 or R40 or R50 in my roof. Well, we have to take a 30% reduction if you have this typical truss detail. So that's really huge. Noyes homes, these zero energy ready homes, they're typically saving about 40% more energy than these new code homes. And one of the high performance details that they're using is also called airtight drywall. And so what they're doing is they have this foam gasket that they put in. It looks like a sill sealer for some of you I've noticed that in the base of concrete walls, or top of concrete walls at the base of your exterior structural wall. But we're using that on the interior and at the top of the wall plates to create this airtight drywall detail. Then they'll also place drywall, screwed underneath the truss and do what's called a blackout air seal, where they'll turn off the lights upstairs in that attic space and then look around and seal all the spots where you see light. So it's called blackout. So there's light down below you, but no light where you are in the attic, and you just go and foam seal all those spots. So between this blackout detail that you'd have on the ceiling and then this air gasket, they're getting ACH 50s, the air changes per hour under 50 pascals of negative pressure, down to 1 to 2 range. I think their average here is about 1.3 ACH 50. This typical home is going to have an ACH 50 of maybe 10 or 12. And so you're about 10 times more airtight than a typical home. That typical home is going to lose 10 air volumes typically a day. And this home is going to lose more like 1 in just through air leakage in the building. Other really cool difference, one is just advanced framing. So you're going to have, if you notice, this whole model is bigger than that one. It's because we have 24-inch on center, so they have 2 insulation bays. This one's 16-inch on center, and there's more framing, across. If it were a 4-foot distance, you would have had another, another 2x6 here. And that framing's not as insulative as the insulation that's between the cavity. So we're both wasting material and we're less insulative. So this is just a higher performing model simply because it has less framing in it. And if you can use less framing in Oregon, which is seismic zone D, you can pretty much use less framing everywhere. So that's another really important detail. I also want to point out that if you look at the insulation, you'll see it's nice and continuous here. And that's really easy when you use this blown-in wall insulation. So we'll call it blown-in bib system. And they're essentially using this kind of spidery fabric that you might see at the bottom of a box spring mattress or something. They'll staple that over the framing and then create these little holes and stick in their tubes and blow in insulation. The cool thing is it fills that entire cavity. And so you wouldn't be able to see that it's filling all around that plumbing, and it does. You wouldn't see it would fill all around the electrical line, and it does. Here, what we're doing is a more standard, inferior, standard batt insulation install. It's really, really hard to do this perfectly, but in a perfect world, you'd have fluff the insulation around that pipe, you'd fluff it around this electrical line. That's not how it actually gets done in the field. It really does get done like this, where it's just stuffed in and stuffed behind things. You lose about 30% of the insulative value of that insulation when you compress it. Then we also have these gaps where it's cut short, just by human error. Sometimes it's cut long, but it gets compressed and squished down. But you have these gaps at the top, at the bottom as well, and you can get what's called wall washing, where you have a stack effect behind that insulation, and you get airflow moving through the insulation, even if there weren't an air leak in the wall. And so that also reduces the insulative value of the wall, and it creates this kind of drafty wall syndrome. So it just takes a little bit of a lack of attention to detail, and you can have a pretty poorly insulated home in that typical newer home detail. Whereas here, we've got an airtight, continuously insulated, more material and energy efficient details. So add up all those details and you get this airtight, super insulated, zero energy ready or zero energy home, depending if you add the solar panels or not. It's a pretty outstanding high performance system. Okay, so we've got the Mitsubishi heat pump outside. And one thing I'm noticing is it's really, really quiet.
Yeah, so a lot of times when we think about these outdoor units from an air conditioner or a heat pump, if we've had them, you think that you have to be like yelling, or you want your windows like to be far away from it because it's going to be so loud all the time. So we just kicked this thing on, and it's going on a pretty high speed right now. and it's still really quiet. So you can enjoy all the time out on the patio here, entertaining, and not feel like you're competing with it if it is running,
Yeah,
when it
that
does need to
sound like,
run.
you know, that kicked on air conditioning unit that we've maybe grown to dislike over the years. And so you mentioned inside that it was a variable speed motor, and so it's similar out here. And my understanding is that's an electronically computated motor, so an ECM motor. I think of it as like turning the dial on a stereo. You can kind of turn it up and turn it down as you want, versus the old school, the pulsating ones, where you basically have the push button, like stage 1, stage 2, stage 3, and they're quite a bit different in their energy consumption. And so this would allow you to use a little bit of energy, or essentially as much as you need to push the air around.
Yeah, that's again a great explanation, Stephen. And what's I think really important about that, especially in our climate, you know, Portland's a fairly mild climate, is a lot of times we only really need a little bit of heat or a little bit of cooling. So when we get into what we call shoulder seasons, kind of, you know, not the peak of summer, not the peak of winter, a lot of times a typical system is just going to have way too much for the house. And so it's either going to be blasting way too much cooling or way too much heat. And it's really inefficient and it's really uncomfortable for the occupants. So by having this variable speed system, we can actually be producing and delivering the right amount of conditioned air and the right temperature to the home, regardless of the time of year.
Fantastic.
Another nice feature about it is it's really quiet, but it's also, I don't know, maybe a quarter the size of a lot of the outdoor units you'd be used to seeing. So we're actually able to install these on the side of homes now. This was one of the first ones we installed, and we put it on the back of the home, and it's almost kind of nice for us on our model home here to be able to have people hear it and see it. But because it's so small, we can still install it on the side of the house, out of the way for everybody, and have plenty of room to walk past it. With a traditional unit and a subdivision with kind of typical setbacks and zoning, you can't do that. So it saves space, it saves energy, it saves money, it's quiet, it's comfortable, it's just an outstanding system.
I can tell you're a big fan. Yeah, and it's literally 1/4 the size of what you would typically see. All right, Mike, let's talk a little bit about some of the specific design considerations now that we're looking at this home from the outside. Maybe we could talk about some of the bits with the siding and what you do there from a durability perspective.
Yeah, so we're in the Pacific Northwest here, and as we know, summers are beautiful. We're standing out here in sun and just kind of blue skies, but it's not like this all year round. We get about 40 inches of rain every year in the Portland area, and we want to make sure that we're planning our houses so that they can be resilient and durable in the midst of all that. Typical siding, a lot of times we refer to it as cladding. It's just, you know, a covering on the outside of the house. A typical siding assembly, even if well installed, is going to only hold out about 90% of bulk water. So if we're talking about, you know, 30 or 40 inches of rain, and we're saying we can allow 3 to 4 inches of water to get behind that, behind the siding, that's not very exciting as a builder or as a homeowner. So there's some house wraps that exist that can help drain some of that out to some extent. But there's a kind of a best practice system that we employ, and it's called a vented rain screen. So what this vented rain screen does is it says, we know that some water is going to get past the siding no matter what we do. We want to make sure that that's able to drain and dry. So we have these battens here that create a 3/8 inch gap behind the siding, and we have a way for the water to get out if it gets behind there at the top of these flashings. And we have what you can't really see very well here, but you can kind of catch in some other details of the house. We have screens that allow for airflow to go through here. Now the bulk of the water is going to be able to drain down, and then anything that doesn't drain down is able to dry out as the air current flows behind the siding. So any moisture that ends up in the wall assembly, not just from rain, is able to dry very quickly and very efficiently. So it's going to make the home much more durable. You know, wood and water don't really mix very well together, especially over time. So we want to make sure we protect that. An additional benefit.
Terrible mix. And I just want to cut you off real quick first. and point out something. You mentioned screens. And so I think what you're talking about is that bug screen at the base of the vent system and at the top, right? Because you're essentially creating this beautiful drainage plane where bulk water can dry out, or if you even have moisture build up in your wall assembly, I think you're pointing out that that membrane is open, vapor open, so vapor can escape out, but it's waterproof, so water can't actually get in. And so you've got this great like drying assembly that could also be an awesome home for little bugs. And it sounds like you've got a way to prevent that.
Yeah, that's a great addition and explanation. The screens prevent bugs from getting in and trying to make a home behind here, because it would be a great home for some bugs, but they still allow the air to flow and water to drain out. An additional benefit of this is that because the siding is able to dry properly, the paint is going to last longer on the siding. So it's going to be lower maintenance, lower costs and less work for the homeowner in the future.
Yeah, so you get less of that absorption and shrinking and contracting, whatever that would happen annually, and just a really great system overall.
So we also use cultured stone, artificial stone veneer products, and so below this area, we're going to have that installed here. And because of the way that installing it over vertical strips or battens isn't going to work well. So we actually use a different kind of rain screen system here. It's kind of like it's a mat, kind of a mat with some kind of woven fibers and curly things that hold it out and allow that drainage and drying potential.
Great.
So we've been talking about this vented rain screen and the screen system that allows the air to go through but keeps the bugs out. And this is an example of what we're using. So you have this fabric here that's going to make sure that no little insects can find their way through there. But then you still have all this great airflow potential and drainage potential through this. So this is an example of what you can't see here and up toward the top of the assembly. Some additional details that we use are these gasketed flashing products. So this blue plastic piece here is what we call a quick flash. It allows us to waterproof and seal and air seal anything that comes out, any penetrations that come out from the house really efficiently. So what the siders have, this is still open and in progress here, is they're going to have this all taped in on the sides and across the top here, and then they're going to leave a little bit of an opening at the bottom. So if there was anything, any water or anything that found its way back there, it would still be able to drain its way out. But these flashing details are a cost-effective but really critical part to a durable and well-sealed home. So as we're walking through our subdivision here, we can see in the background this White House is one of our model homes out here. And up on the roof there, we have the solar installed that makes that home an actual zero energy home and takes it from being just zero energy ready to actually zero energy. When we're looking at solar, we need to make sure that we preserve some roof space for that, and we keep different penetrations out of the way. So we have plumbing vents or roof vents that can be installed and can be a large problem for having those panels there. Can just really interrupt the spacing. So by making sure we keep those out of the way, we're able to install a nice clean system like the one we see. By making sure that we preserve and plan for at least a large section on every home, if not more than one section of roof space, we're able to take those homes from being just highly efficient homes to actually being zero energy ready, and then having the potential with solar installed to be truly zero energy.
That's really inspiring. It's so cool to see. It looks like about a 10 kilowatt, maybe 11 kilowatt panel system up there. And just thinking from like a resiliency standpoint, how fantastic is that to really understand that you can provide as much energy to the grid as you take from the grid annually with just something as simple as that on your roof. Really, really fantastic.
Yeah, solar has come a long ways, and it's much more affordable than it used to be. And so it's actually at the point now where if somebody's just looking at it from a dollars and cents standpoint and not thinking about the impact that they're having on the world, it makes sense. The math pencils out for somebody to either break even or save money. A lot of times now we're even seeing people saving money by installing this on the roof of their home.
Great. Love to hear that. Okay, so now we're here with Mike in my favorite room in the whole house. I mean, I'm a fan of good architecture. There's a lot of great architecture inside. But here we've got some amazing details. We saw some amazing details on the outside of the home. Really outstanding, high performance work happening in here. So I want to point out a few things. Mike, maybe you can walk us through as we talk about them. I see, of course, over here is where you're going to have that 97, 98% efficient Navian gas hot water heater. And then your rough-in pipes for your central vacuum system, correct?
Correct, yeah.
Well, as we move along, then I'm seeing like a little hole here for a fan. And let's talk about that for just a moment. Why are we going to put a fan there, Mike?
So we're in the garage, right? And what kinds of things go in the garage? Cars. Yep. Some cars are electric and aren't going to have the exhaust coming off of them, but they're still going to have, they're still going to be off-gassing things.
Now you might have your paint in here. You might have well, of course, if you do drive your car in, then there's like benzene and all these particulates that you probably don't want to send to your kids' bedrooms or whatever else. But certainly, we put all of our toxic garbage in a garage. Whatever we own, all the stuff that's got the skulls and crossbones, or even if it doesn't, the things that smell, I put them in my garage. I wouldn't put them in my house. And so it ends up here, right?
And so, like you said, we have all these things in the garage, and a lot of times the rooms above the garage end up being kids' bedrooms. So if you think about the potential for all the nasty stuff you keep in your garage to be just kind of finding its way up into your kids' bedrooms or into your house, it's not a very exciting proposition, right? So we do a lot of things, and we'll see some of it as we look around to make sure that we seal the house off from the garage very carefully so that they're separate spaces. But in addition to that, we installed this fan. And so right now it's the actual motor assembly's not here, but this is a fan that it's connected to a motion sensor. So every time somebody comes out into the garage or you pull the car in and out, this fan's going to turn on, and it's just going to exhaust the air from the garage. By pulling the air out of the garage, we're just helping ensure, even beyond the sealing that we've done on the house, that nothing's going to be going into the house, and even the air in the garage is going to be a little bit cleaner as a result.
So, you pull in the car, that's going to run for like 20 minutes. And so the car's off, and all that exhaust is just being sucked out and going to the outside. And so when you open the door, it's not going to follow you in because the space is under pressure, and all that air from the inside of the home will just rush out with the toxics out through that fan. That's really amazing. I'm noticing also a whole lot of air sealing and super insulation details, and maybe we can kind of look at a couple of those really quickly. So maybe point out some of the things that you think I might be seeing.
So we have a number of air sealing details, like you mentioned. One thing that we have here that you don't see a lot of places is we have this self-adhesive flashing. Basically, it's like sticky tape, but it's a little more durable than that, and the adhesive is going to be better. So we take this and we run it underneath the bottom plate of framing, which you can see bottom plates over in the corner there is an example on an exterior wall. But we run that underneath here, and we flip it up, and then we run our drywall over the top of this, and that creates a really nice seal along the base of the wall here, and it helps ensure that there's no air leakage between those spaces. You can also see this kind of pink and white spray foam, and that's used to seal around anything like this electrical outlet or these different pipes that are coming from the house to make sure that we're airtight from the house to the garage. Above us, we also have this blown-in insulation, and typical insulation with bats that are kind of like big blankets that people are used to seeing just doesn't install as well and doesn't have the same insulative properties. So what we have above us is this really incredible amount of insulation. It ends up being about R59 between the garage and the house above. And that has the benefits of creating a more comfortable environment and being more efficient inside the home. But it's also something that's going to make the home quieter, because when the garage door opens and closes, or the cars are coming in and out, the people who are upstairs aren't going to be hearing as much noise.
And moving along this wall system, so you see the amazing air sealing details, super insulation details, and the clean air details. I'm also noticing there's a electrical line coming down from maybe the roof or something to this square box over here. Can you tell me what's going on with that?
Absolutely. So all of our homes are solar ready, and that's actually a pretty simple thing to do. To be solar ready, the main things that we need to do physically are we run this pipe, this conduit, between the garage and the attic space. And that allows a solar contractor to come and pull a wire between the two spaces. So we have this nice box here where they can come out with that wire, and then we reserve space on the panel here to make sure that we have room for additional solar to be installed. If you had a panel that was fully at capacity and you were solar ready but you couldn't actually hook it up anywhere, it wouldn't be very useful. So this pathway between the garage right near the electrical panel and the attic is what allows you to connect the panels, the solar panels, to the electrical panel in the garage here.
That's fantastic.
So I guess the challenging piece, we can talk about this. This is really fast and easy to install. Energy Trust of Oregon currently has some solar-ready incentives that offset this cost or eliminate this cost ultimately for a home builder. Where the challenge comes in is not just running a path between the two places, but planning the roof and preserving the space properly for the solar.
So that's a really great point. So here in the Pacific Northwest, in our region, we're in a, very specifically because you're PGE, you have Energy Trust of Oregon as a potential partner in facilitating high performance details like this solar ready home. And everything costs a buck, Mike. So, with or without those incentives, how expensive is putting in something like this?
So the actual cost and labor that goes into this is just a couple $100s. It's going to depend on your contractor and how you negotiate that with them, but it's really not very expensive. It doesn't take a ton of material or time. So this is very low cost, something that everybody can and should be doing.
And so Energy Trust of Oregon will offset those costs for you if you're in that zone, and even if you're not, we're talking for a high performance detail like this, a couple $100. Yeah. So that's pretty awesome.
So in addition to our solar, we actually have all of our homes come standard for a car charging location. So this outlet is kind of the typical power for most cars. It'll have the typical NEMA 1450 plug that most electric cars would plug or would charge from. So if somebody wants to just plug in the cord that comes with their car, they can plug in and charge quickly here. Or they can install a mounted charging system here, and they have the power for it just ready and standard.
That's great. All right, let's maybe head into the rest of the house and dig into some of the other details. So Mike, one of the things I noticed coming in here is that we're in a development with a lot of new construction going on, multiple homes being built around us all at the same time, beautiful coordination there. We walked in here and it's almost dead silent. And you only have the temporary doors on the outside of the building. They look, I can see a lot of daylight on those. Those are not super airtight or insulated themselves. It seems like you got a lot of high performance insulation details. Maybe we can talk a little bit about those and some of the ones that we can see right close to us.
Absolutely. When you think about some of the current state of construction, like you said, we have these temporary doors installed, and we don't have any drywall up. So that means that we're just open to the framing upstairs when we get up there, and yet it's still really quiet in here. One of the main reasons for that is we use these blown-in blanket wall insulation systems where we dense pack and blow in insulation into the wall cavities. So that's supposed to be really energy efficient. That's why we're doing it, really. It installs very well, gets around all the different wires and ducts and or different things that are running in the wall and pipes and all that. And it gets this really, really dense, warming insulation, but it's also going to make the home really quiet. So what's not the primary purpose is an end result that is pretty enjoyable for a homeowner, knowing that their home is just going to be really quiet to the outdoors.
That's great. And I So I can see the bib system in the walls, and then we can move up the walls, and it looks like you have some polyisocyanurate. Is that correct? Some insulation board above the window. Can you talk a little bit about that and why you chose to do that?
Absolutely, Stefan. So, we have structural headers. There are these large beams that go above windows because of the loading that comes down on those. And wood's just not a very good insulator. So while we need that for structure, we have the amount of wood that's required, or the thickness of that header, still leaves some room where we can put some insulation there. Now, if we just tried to put a little bit of this blown-in blanket or a fiberglass bat there, the density of that insulation and the insulating value of that is just pretty low in such a small area. So we take this really high density and kind of super insulating foam board, and we put it in the little space that the header leaves to come out to the framing. And so what that gives us is an R value of about R9 or so, depending on the amount of room that we have there. And the difference between that and just having the wood there is pretty substantial, because you've essentially just doubled your insulation value up there.
So as I was growing up in the construction industry, one of the jobs I had was going around and stuffing fiberglass next to the windows, right? Tell me why I see you're taking a different strategy there. Maybe talk about why you're doing that.
By using this foam, it's a low expansion foam, so it's not going to cause the windows to buckle or have operational issues. But we're able to quickly and efficiently go around the edges of these windows and insulate them and air seal them. So that's going to, again, make for a more comfortable home and a more efficient home. In addition to that, what we can kind of see at the bottom of the window is what we call a sill pan. And that's where we have this self-adhesive membrane or flashing system that kind of comes up about 6 inches on the side, runs along the bottom of the window, and comes back up the other side. The inside of that is caulked to create a back dam on it. And you can't really tell here, but the bottom piece of wood below the window there, the sill is actually sloped away from the home. And that means that if any water kind of finds its way along the outside, the edge of that window, it's not going to be able to come in at the bottom, and it's going to be directed, and it's going to drain away from the house. So that's another kind of exciting little detail that we can see inside the house while we're looking at this.
That's great. So it's open on the other side and all sealed up from this side. So any water that gets there can just drain right out. Love it. And yeah, my fiberglass technique probably wasn't very good at air sealing either. So, all right. So one of the things I also noticed when we walked right in here and look up is all this ductwork up in the ceiling. And so, Mike, let's just talk to everyone a little bit about that.
Yeah, so what we do with all of our homes is we put the ductwork inside the conditioned space of the home. A lot of typical construction, you would see all these ducts. They'd be wrapped in thin insulation, and they'd be running in the crawl space or in the attic, and those aren't very comfortable or exciting places to be. So if we think about that is, if I don't want to be in the crawl space or in the attic, do I really want my ductwork to be there, as that delivers the air to my home and moves the air through my home? We're going to go ahead and say that that's not the best plan, and that we want to have the ductwork inside the home. It's going to be more efficient to run it this way because you're not running through a cold crawl space or a hot or cold attic. And it's going to be healthier because you're not running through those spaces where the air quality might not be very good. So we keep all of this in the conditioned space, and we use these open web floor trusses. They're basically 2x4s with triangular openings between them that allow us to easily get the ductwork and all the plumbing and other wires through. We also, even though this is inside, we seal all the edges. So you can see this kind of gray goopy stuff that's mastic, and that seals the ductwork because we want to make sure, even though it's okay if a little air moves out to the rest of the house because it's inside and we're not losing it outside, or we're not pulling something in through it from outside, we really want to send the air where it's supposed to go. Each one of our homes, we go through and we use this software to size the system and size each run to every room specifically for the home. So this isn't something where it's like this plan gets it done that way every time. They take into account the orientation, the way the house is facing and the kind of sun exposure that it's going to be getting, and all the exact details of the home. And then they size the system. And we actually test to make sure that we're getting the airflow that we said we needed within a reasonably acceptable range to every location.
So you're commissioning all of your ductwork against what you modeled from an energy standpoint. So you're saying, okay, for energy model is telling me we need this much heating and cooling energy, and so we need this much ductwork to make that happen. And what I'm hearing is you're both doing that part, super important, and I'm also hearing that you're verifying it. And so is Earth Advantage helping with that verification process, and what does that look like?
So that's absolutely correct. And our heating and cooling contractor comes in and they test and measure the airflows both during rough and finish. And Earth Advantage, as our third-party verification program and partner, they come in at 2 different stages. They're going to come into the house right about now when they can see all the insulation, all the ductwork in the house before drywall. And they're going to come look at things and check for anything that doesn't meet the standards of the program. Now, our hope and our expectation is that we've done such a good job managing the house up to that point that they don't have anything to point out to us. But as we know, nobody's perfect. Nothing's ever quite perfect. So having that second set of eyes is really valuable to us as a home builder. We know that they're going to come through and they're going to be helping us improve the quality of our home. It's a partnership. It's not like they've got the red pen and they're marking up the paper and making you feel bad. They're helping us improve. So they come through at this stage, then they come back again at the end of construction and they test and measure things in the finished home. So those 2 inspections are key times where they're able to see the stuff before it's finished and they're able to come and verify everything after it.
So let's talk about that. So seeing stuff before it's finished. Like you're a big critical part to this whole enchilada here that you're putting together, which is this very efficient, healthy, durable home, is the airtightness of this building, correct? And I noticed that this particular building's energy performance score shows it's about 40% more efficient than a new home to code, built to essentially 2020 energy efficiency requirements. This home almost saves half of that amount of energy. And so I imagine you're doing a lot of air sealing details and that's critical. And so you said there's a verification right now. Can we talk a little bit about that and why it's important to do now?
So, so many of the details that are critical to the end performance of a home are things that could be skipped and buried and never addressed. So when we talk about the insulation value or the quality of the ductwork that's installed or the air sealing that we've looked at along the edges of the house and the windows, once the drywall's up, you never know if that was done properly. So having that inspection beforehand is going to help identify any issues and provide peace of mind for us and for our customers, knowing that another party, another program has come and looked at this. If there are any spots where, say for an air sealing example, where there's a spot that the insulator missed, or maybe they were using a can of foam and it ran out and they went to get another one and they missed picking up right at the right spot again. It's just another time where we can catch any of those details.
And right now it looks like I can see everything. And if I can see everything, fixing it seems pretty straightforward. And I've fixed a lot of drywall in my life and I don't like that at all. And I would imagine that's pretty expensive if you finish this home and you're not meeting your insulation and airtightness requirements that you're selling to your client. This is a huge opportunity right now to get that right inexpensively before you figure it out when it's maybe too late.
Yeah, so anytime you have the opportunity to do something right the first time or to catch it before it's moved on to the next stage, it's going to be more efficient, it's going to save money, and it's going to just save a lot of time for everybody. Like you said, if you're kind of having to come in and try and fix something after the fact or chase something after it's covered, it's a really difficult situation to find yourself in. So, in order to build a highly efficient and, zero energy ready home, all of these details really matter. Having the ductwork inside is one of the main steps to that. Having proper air sealing is one of the main steps to that. And honestly, between those 2 key pieces, I think that's what's going to be a challenge for a lot of builders. It really isn't that hard to get a very well-sealed home. We're not using a bunch of crazy technology or fancy thought processes here. It's just an attention to detail and some very readily available products. But we're able to consistently deliver a home that is far more comfortable and more efficient than what the average new home is, as you've mentioned. A lot of times people think, I'm going to buy a new house. It's going to be well built and efficient. The reality is, if we're staying in a home right now that's about 40% more efficient than another brand new home, there are different levels that you can find. And then when you start looking at existing homes, if a new home is 40% better, think about where an existing home
We're at least
lies.
twice as efficient as an existing home, according to that energy performance score. And a home like this built new, we're probably somewhere in the realm of $250 or so a month worth of energy bills. And the ability to offset that maybe hasn't been built in at all, right? So there's probably not solar ready, and there's not going to be solar on the roof that could offset a majority, if not all, of those costs. And this home's probably, if we take that, 40% of that would be probably $100 a month. And what are you finding? When you get those energy performance scores, are you meeting those targets? Do you find that your feedback is that homeowners' bills are that low? Is that an expectation maybe that's happening with your clientele, that they see those numbers, and what's the feedback on that?
So the energy performance score system that's in place is definitely accurate. It makes some assumptions, and it's going to be based on these modeled homeowners. And not every family is the same. Not everybody's habits are going to be the same. But your typical family, and this is what's important, your typical family is going to see an energy performance end result and cost that's very similar to what's modeled. We've seen those be highly accurate so far. I think that a lot of people, or I know for myself, when I've looked at them, I've used less energy than the model said. So I think there's a little bit of room in there for a lot of families to come in under.
The bottom line is that you're starting already, right? If your typical home is using that much more electricity, and this home is using that much less, then whether you're driving, however you drive fast, you drive slow, if you're driving the Prius, you're going to use less gas than if you're driving the Suburban, right? It's just how it is. Yeah. And so I think that's really telling when you look at that miles per gallon, or in this case, energy performance score. It really translates to real savings for homeowners. And I think that's just something that we haven't had until just recently. I really think it's going to be huge for the future.
Yeah, I agree. Having that measured value is critical.
Okay, Mike, so we talked about the insulation in the walls and the cool thing about the insulated headers. Now we've got these windows. And so my understanding is that you've got a really well insulated wall, but then you have a not very well insulated window that can really drive down the overall performance and maybe comfort in a home. So what do you do here to rise up to that challenge?
Windows are definitely an area that can be inefficient. The window is never going to perform quite like the wall, right? But we do like natural light, and we like natural ventilation when the weather's appropriate for that. So windows are a good thing. But what we have here is what looks like a just pretty normal vinyl window. It's a Milgard window, locally manufactured here in the Northwest. And even though it looks pretty normal, it has a number of different features that make it highly efficient. So this is still just a double pane window. We just have 2 panes of glass here. But they have some coatings and some different kind of gases that are filled in between, and some seals and whatnot. Some of that stuff, the kind of low E thoughts and some of the like argon and different things that they put in windows, those aren't really feeling that new to people anymore. So they're way better than an old window, but they've been around for a while. Kind of a newer method here. Milgard refers to this as a fourth surface coating. So what they do is they put an additional coating on the inside of the glass here facing into the house. And what that does is it essentially reflects the heat back into the home. So we're in a heating dominated climate. We get some nice summer days, but most of the year we're going to be in a heating season. So that's really beneficial to us. On a cold day, you can actually walk up to this window and you can feel, if you hold your hand just a little bit off the glass, you can feel the heat that's coming from your hand kind of radiating back at you because of this fourth surface.
Outstanding. That's fantastic. And so for some of the builders or other people listening to this right now, there's 4 surfaces, right? Because you've got those 2 panes of glass. And so you've got that outside pane, you know, surface 1, inside of that outside pane, 2, inside of the inner pane, 3, and then this. Now we've got a 4th surface. And what I'm hearing is we're putting these like thin kind of metallic coatings that are both reflecting out some of the UV that the unwanted heat gain might have that surface on the outside. But then also we've got stuff all the way on the inside now that can reflect that heat that we provide, that we're kind of like our own sun inside, right? Sending out heat and electromagnetic waves. And we can send those to the windows, and now the windows can send that back to us. All right?
Another great explanation, Stephen. Yeah, that's absolutely correct. And kind of just a fun fact is, you know, we talk about infrared cameras sometimes, and to see this in just full motion, if you're standing in here on a cold day and you pull out that infrared camera, you can just see the heat from your body coming right back off the window, right at you on that infrared camera. It really does work. It's not just a gimmick.
So great. Cool. So now we're upstairs looking at some high performance insulation and air sealing details. And so I can see a variety of things. And maybe it would be great, Mike, if you could just kind of walk us through some of the stuff that you think I might be seeing right now.
So we have a number of things that we get to look at right now. We've talked a little bit, or we can continue talking about this foam sill seal. It's this little pink foam gasket, and it's something that we've used in construction for years between the concrete and the bottom plate, the green plate there. It's serving a different purpose here than it is there. So what this is doing is when we put the drywall on the framing here, and we have a space up against the attic, that's creating a gasket. So the drywall presses against that, and it seals, air seals up against there. And that prevents a lot of the air from passing between the walls and the attic. Most of the air loss from the house actually goes, we have a stack effect in a house, so air kind of comes up and out. And by sealing up these top points, we're creating a much more efficient house, because that's a great spot for leakage that we don't want to have. So this very simple product, very inexpensive. You know, somebody can come out here and roll this along. They use a stapler and staple it up there. Everywhere that the house is meeting an attic space, it's a very cost-effective but very effective air sealing measure for just a couple $100s.
I guess what I'm hearing right now from you is that that's a really cost-effective one.
Well, yeah, one of the most cost-effective air sealing options we have is that simple foam gasket. We spend some time, and not a great deal of cost, but some time with also some different foam locations at the penetrations, like where that pipe comes through.
So tell me a little bit about, we're in the middle of the home now. This is not an exterior wall. We're actually in a bathroom where a master cabinet probably is going to be at some point. And so why would you air seal this interior wall?
The amazing thing is that a lot of air ends up finding its way into wall cavities, and because this is next to the attic space, that's going to be a spot where the air is going to be able to move between the two spaces. So even though we're inside, we're still connected to outside, and sealing up every point you can really just comes together for a much tighter home.
Great. And I'm also noticing, as we look around, that we've got some maybe high performance attic details. Can we talk a little bit about that?
So our attic trusses are intentionally planned to allow for insulation. We put extra insulation in our attic compared to kind of older homes or typical homes. And in order to have that space, you know, out in the middle of the house here, there's lots of room. But as we get toward the edge, the way roof framing works, you get closer and closer to the edge and you're running out of space. So what we have is we have a raised heel. So instead of getting pinched down in the corner, we take the end of the truss and we make it taller, and we leave extra space for insulation all the way out to the outside wall. So if you were to look at a typical house and you get that kind of pinched off space, you're getting almost no insulation in the corner. And especially if you have a hip roof location, like we have in the corner of our house over here, where these two planes are coming together and they're both pinching off the corner, there's a lot of lost insulation space there. So by putting this raised heel up, we're able to get a lot of insulation out to the edge. We use an 11¼ inch raised heel. There are different sizes that you can have done. That 11¼ is going to get us somewhere around an R28 edge. Kind of depends on the value of the insulation. But it's going to get us about that all the way out to the edge, compared to little to nothing out there.
That's outstanding. As we'll learn also from thermodynamics and our modules around building science and just high performance wall systems, is that high concentrations of moisture and temperature like to go to low. So in the winter, it's going to be actually relatively dry outside, and we're in a bathroom right now, so it's probably going to be kind of humid, and that's actually where that corner is. And so in a typical home, you might have all this warm, humid air trying to escape, where you have a lot of materials all meeting each other, where it's probably pretty air leaky. And if there's no insulation there, it's going to be cold. And just like the way the steam hits the mirrors and steams up the mirrors in our bathrooms, it's certainly going to steam up and load moisture into that exterior wall. In this case, you've really helped prevent that by you've air sealed that corner, right? We've got the gasket. You've got super insulation, so it's also not cold. So kind of those two partners, air sealing and insulation, really help to prevent that, that moisture leakage. And ultimately what really degrades buildings is that moisture, either from the inside trying to escape out or from that bulk water trying to get in. So real belt and suspenders is the way I like to think of this, between your exterior rain screen that we talked about and now this air sealing and super insulation details on the inside.
Yeah, absolutely. And in addition to that, we have a really great quality bath fan in here. Talk about the moisture that's building up in the room. If we can have a quiet and efficient fan that can remove that moisture from the home, it's more likely that people are going to use it. So we put a timer on here, and if people just, when they're going to take a shower, they hit the timer and they let that thing operate, it's going to pull the moisture out of the room and prevent it from building up. And because it's so quiet, it's not a nuisance for people, and it's very efficient, so it doesn't use a lot of energy. One other thing, as part of our Earth Advantage certification process, they actually come in at finish and they test these fans to make sure they're doing what they're supposed to be doing. What you can see sometimes is they're little dampers, kind of flappers in the fan systems, and sometimes those get stuck. And you can turn on the fan and it sounds like it's working, but if you actually measure the airflow, you can find that it's not. And if you don't have the airflow working properly in the bathroom, all that moisture we're talking about isn't being removed properly, which can be a big problem for homeowners and builders.
So that's a really great point. We're in a bathroom right now, and verification of this stuff is so important, right? Because there's plenty of bathroom fans out there that are blowing air to nowhere. Trust me, I've done a lot of remodeling in my career. And so just knowing that we've got the bathroom fan exhausting out and verified for that is really important. We talked about Earth Advantage as a certification for this home, and that's Earth Advantage Platinum, right? They, like LEED, have a very similar, precious metals certification system, right? Where Platinum's at that highest level. And my understanding is it's not just about energy efficiency, right? That we also have these other pillars in that certification program. And so some of those would be like water, for instance, right? Health. And maybe we should start talking about some of those in just a minute. But I want to energy, and we have site is another important pillar. Also have another layer of certification behind them, right? So not as many maybe are as familiar with WaterSense, but that's also a standard by which the certification is looking at. So you're going to have your WaterSense certified low flow toilets, and you're going to have aerators on your sinks in the bathroom, and in your showers, you're typically going to have some low flow shower heads. And All of this stuff gets points, but there's also within this whole area, there's these tiers of certification. Energy Star being the energy piece, WaterSense being the water piece, and then we've got the EPA's Indoor Air Plus, which is the air quality piece. And all of that can kind of roll up into a single Earth Advantage standard. They're not mutually exclusive, and in fact, to get that certification, you actually do have some of these other certifications rolled in.
Yeah, a lot of the certifications really pair well with each other or share a lot of the same values, and I think that's for good reason.
And so really, Earth Advantage becomes kind of a critical partner in all of this and helping keep us accountable and keep Noyes accountable on all of the different steps, and because it's easy to forget, right? Like, oh, yeah, because not only are we making this zero energy ready, have all this geeky stuff with the solar, we've got this heat pumps, we've got all this complex stuff on the energy side. Oh yeah, water, that's super important too. So now I've got low flow toilets and aerators in my sinks, and oh, health, that's right, materials is an important part of health, because we were already focused on the air quality and all these other elements, right? So a bathroom, you kind of have all of that coming together. Yeah. And I think one of the important parts in a bathroom too, which is typical, is you'll have hard surfaces in a bathroom. It's pretty typical. You still do see some carpet in bathrooms, but
not a great idea, no.
No. And so I have noticed over the years there's been a transition to less and less carpet and more hard surfaces.
I think there's a lot to why people are gravitating toward these hard surfaces. There is an element where they tend to be kind of luxurious and desirable, and so it's kind of a status thing in some ways, where you can go, well, look at all the hardwood floors I have, or how much tile I have. And so there's a piece of that. They're beautiful, but then the kind of benefit to all that I think people are missing in the aesthetics of it is that they're clean. So carpet, it kind of just traps all this stuff in it, and you can vacuum, but it's not really gonna get all of it out. But a hard surface floor, while it looks dirty faster sometimes, that's actually you just seeing the reality and being able to more efficiently clean that. So it's going to improve the indoor air quality dramatically. We use a lot of hardwood flooring on our main floor, and we use a lot of hard surface flooring in all our bathrooms and our laundry room.
So you're getting some health points in that health pillar for having those hardwood or hard surface systems. And meanwhile, you're getting points all across the board in a space like this. One of the other details that we may not really be able to see, but we might even talk about just quickly on the performance side as we jump around a little bit, is this tub. How are you managing the tub installs maybe a little bit differently from an energy performance and durability standpoint than maybe was happening 10 years ago?
Yeah, so we've talked about things that are done in sequence, and how if you do something right first, it's a lot easier than going backwards. So a tub location, and this one being a big, nice soaking tub in the master, what can end up happening is you can end up with these spaces behind them where they're not sealed, they're not air sealed. And insulation is supposed to be in a 6-sided box with contact on all sides. And if we leave that open, it's not going to perform like it's supposed to. Air is going to be able to move through it, and you're not going to get the value that it's rated as.
So it could be a real durability problem. You got a lot of moisture, airflow, and no insulation. Sounds like a recipe for mold and condensation nightmare, right?
Yeah, so behind all of our tubs and or exterior locations similar to tubs, fireplaces are another example where you have this cavity that can kind of come in. We go and we place a rigid air barrier. So it's pre-insulated, there's insulation back there, and there's a rigid air barrier. There's a solid barrier on the inside, even though it could have been an open cavity. And we're able to seal that and ensure that we don't have those durability issues that you're mentioning. So at our tub location, all we do is before our framers frame this, we have them take a piece of OSB and they run it along the back. And the insulation contractor is able to seal around that, and then they're able to just blow the insulation in behind it. So we get a nice barrier there. Behind like a tub shower combo that the plumbers are going to install and there'd be no access to, we have a pre-insulation stage where they come in and they put some insulation up and they put a rigid board up behind that to air seal before that gets installed.
So that's super great. So before this tub goes in, essentially, you're going to have that OSB, that solid surface that's up, because when you blow in this bib insulation, you've got that netting that you put up, right? But if you put that netting up and just blew down in there without a solid surface, then that's just going to blow around the side of the tub, and you may not fill the cavity at all, right? So now you've got a solid cavity, so when you blow into that netting, it's going to fill that whole cavity all the way up, and was able to be air sealed before. So another really great high performance detail, and yeah, it just seems like between that detail, this raised heel truss, a continuous, these super energy efficient quiet fans, sealed gaskets, aerators to reduce the amount of flow of water out of your showers and your sinks, low flow toilets. There's a ton of stuff just going on in this bathroom. Hard surface flooring, right, that impacts air quality. It's going to impact durability, right? It's going to impact people's comfort and ultimately health, and brass tacks, energy efficiency. So yeah, a lot to be really proud of in such a small space.
Yeah, and there's even one more thing that we do with our plumbing systems to help make sure that we're delivering the water, the heated water in particular, as efficiently as possible. So there are different plumbing systems.
So you don't just run the hot water all the way around the exterior of the house?
Right. So a traditional system is called a trunk and branches system. And there's a large trunk that's then feeding off to all these little branches that come off of it to the different bathrooms and different fixtures. Now every time you try and run hot water to those spaces, you're trying to run it through that entire trunk. So not only is that going to waste a lot of water because you're filling that every time, but it's going to slow down the delivery, and people want hot water fast. So what we do is we use a modified manifold system. A manifold's a lot like when you picture an electrical panel, where each run goes exactly where it's supposed to go, kind of. But what we decided is we can combine a trunk and branches approach and a manifold approach, and we can create like mini trees, mini trunk and branch systems to different rooms. So a small pipe, because we use these low flow fixtures, a small pipe can actually deliver enough water flow to this entire bathroom. So if we run the one small line to it, and then we branch off from that, it's going to efficiently deliver that water. And one of the benefits you'll find here is if you run the water at one sink, it's gotten through most of that main line, and it's already going to be kind of preheated and ready for the other sink or the shower.
All right, Mike, so I was just in the little mechanical room right over here where I saw the beautiful Mitsubishi air handler and saw some pipes coming into it that look like they're sending out supply, heating and cooling that we saw through the ceiling below. And I noticed a big pipe that comes into it, which is right above me, which is kind of the return air to that system, which I notice you have a bunch of insulation around that return air. And so can you tell me a little bit about that and just your attic insulation strategy real quick?
Yeah, so we talked about the benefit of having ductwork inside the house. And then we have this giant part outside of the house in the attic. So what we do this for a reason, though. If you have a short run for a return air location, sometimes that can produce noise. So we want to get enough distance here that we're not going to hear the noise from the system running through that. So we run this through the attic, but then we want to make it like it's inside. So we actually use this strategy down in the garage too, where we create a false like interior. And so we created this box all around this ductwork, and we air seal that box, and we attach it to the house and separate it from the outside or the attic. And then we also wrap it in insulation, and then when we insulate the attic, we use a blown-in insulation, and we kind of pile it around there, mount it around there, and insulate around it very well. So what this gives us is a return air duct that's essentially inside, and while it's not quite as efficient as if it was completely inside, it works very well, and it brings it close enough to the conditioned space to not lose the efficiency out of it.
And really cost-effectively centralize your heating and cooling system. And then your insulation levels up in the walls there, or the attic, sorry, in the ceiling. What is that?
So we use an R49 insulation level. That's a much higher level than existing homes would have. And in the Pacific Northwest, in our climate in particular, you see diminishing returns on that. So you can go up to maybe an R60, but really R49 is pretty much the sweet spot for getting a good value and good insulation amount.
And we didn't really talk about it, but the walls, what's the insulation level on those walls too?
So the exterior walls end up being an R23 insulation value with that packed in insulation in the 2x6 cavity. And it's a true R23 because of how well it's installed.
That's so great. And all of those numbers, by the way, well exceed code requirements. The walls are just a few points up, but you have a limited space. But we're getting what's required is close to about R38, and you're going all the way to R49 in that attic space. That's really fantastic. I also noticed another pipe coming into your air handler here, and it had a little box on it. It looked like maybe a mechanical damper. Can you tell me a little bit about that?
Yes, we build these incredibly tight homes, right? We've talked a little bit about the air changes per hour. We'll talk a little bit more about that in the finished home. But see, these are very tight homes, and we don't have a lot of leakage coming in from outside. And homes don't need to breathe, but people do. And we have people in our homes. That's why we're building them, right? So we want to make sure that we're delivering air to the home. We actually intentionally decide where it's coming from. So we use this damper in there, and there's a fresh air duct that comes from outside, and it runs its way in, and it connects at the air handler right above the filter location. So that damper is on a timer, and this timer is programmed in to provide the proper amount of ventilation for the occupants in the home. And it automatically turns on when it needs to. It runs the air from that damper through the filter, through the ductwork, and distributes it to the rest of the home. So we're getting the air everywhere in the home that we want it to be, and we're filtering it first, which is great. People with allergies are going to want that
fresh
filtered.
filtered air from outside coming into your main duct plenum and then being distributed throughout the entire home. And the filter on that, what is the filter level?
So we've recently started using a MERV 13 filter. The efficiency ratings of filters, have a range much like other things. And you have to ensure that you get good filtration, but you still get good airflow. So a MERV 13 filter is able to take care of a lot of the dust and allergens and mold spores and things like that that could find their way through homes. And it's going to filter all those kind of common things out very well. The benefit of MERV 13 is that it also has filtration capabilities towards bacteria and viruses. It's not like a HEPA level, but it's really good.
And so you're getting close to a hospital quality air filtration in a home that can filter out viruses, pathogens, bacteria, and my understanding is also wood smoke, which in the Pacific Northwest is becoming more and more common that we all have wildfires, and being able to filter that out when there is a problem, I think is really huge. My building science mind is saying, well, if you're bringing air in, aren't you pressurizing the home? Like how? And could that push moisture into the wall assemblies or something like that? So how are you dealing with that piece?
Yeah, are we blowing up the balloon with our tightly sealed house, right?
Yeah.
That's a great question. So we bring that fresh air in, and we have that timer that's controlling that, and that system also interlocked and connected to this quiet and highly efficient exhaust fan in the laundry room. So the air coming in is roughly balanced, not perfectly, but pretty close to balanced by the air going out being exhausted from that laundry room fan. Every time the timer calls for, or the system calls for fresh air coming in, stale air going out. It helps move it through the house, and it keeps us from pressurizing or depressurizing.
Awesome. So I'm trying to wrap my head around all of this because just from an air quality standpoint and health, we've got roughed in central vacuum system. There's these 2-inch lines that we can see running through the home. And that's standard for you guys, right? So you're going to rough that in regardless of people saying they want it or not. They can always plug that in later. And what that does is constantly, you go around and vacuum. Any of those particulates that go up in that hose, those go outside, right? Then you're taking fresh air from outside, and if you're somehow in some remarkable way, some of that particulate made it around, it's going through a MERV 13 filter that can eliminate bacteria, viruses, pathogens, particulate matter 2.5, which we'll talk about maybe in a module someday, and ultimately bring in fresh, filtered, healthy air, distribute it through the house. You're not creating a pressure situation because you have this balanced other fan that's smart, and it's going to exhaust while it's pulling in air. This is really brilliant. And then we've got things like hard surfaces, more predominantly in the designs than we ever had before, right? And that's to try and minimize the amount of dust that can kind of accumulate below the carpet, you're saying. And then that dust, when you vacuum it, maybe you don't hit that little spot, or maybe the vacuum can't quite get that dust back out. So you stomp around and the dust gets back up in the air. So we've reduced that. And then there are things like volatile organic compounds. And I hear that you're using low or zero VOC paints on the inside of the homes and just healthier materials. So talk a little bit about that too.
So we think a lot about the products that we're using. We use a lot of products, like you said, that are low VOC products, low VOC paints, and we're intentional to, no added urea formaldehyde products in our wood products and things like that.
That's carcinogenic, and it's pretty predominant, right? You have carcinogens in these glues that, if you don't minimize, can be a real problem.
Yeah, and any carpet or carpet pad that we use is Green Label or Green Label Plus certified. So it's also supposed to have less, volatile organic compounds and be a healthier.
And chemicals of concern that we'll talk about in modules too, that also, are building up in the environment and building up in our own homes. So those certifications also help verify that we've eliminated a lot of these nasty toxics. And so that's pretty incredible. That's just in one pillar of health. And so I'm certain that I would want to have someone helping me check off all of those boxes just in that one thing, because I can't even remember everything we just talked about, let alone energy, which we've had a lot of conversation about, and water, which is a whole nother thing, right? And we've talked a lot about the water inside with low flow fixtures and aerators, right, to make that happen, the low flow toilets. How are those working, by the way, the low flow toilets?
I know there's been some press and some questions about low flow fixtures from some high places, but we haven't had any problems with them. The toilets flush just fine. The shower heads get our hair plenty clean. So.
And then you're not just thinking about water inside, and those systems work. And I have the same feedback. I drink the Kool-Aid, and my home's filled with all this equipment, and it works really, really well. But also you're thinking about water use outside the home. And so you've thought through, how not to waste water waiting for the hot water to come. You've got these trunk lines coming off, or your manifolds, right? You have multiple manifolds. Maybe we get some shots of that. But you're also thinking about the water usage used on site, because you have this neighborhood and beautiful landscapes. And what are you doing for water on the outside of the home?
So we do a few things for water quality or water consumption on the outside of the home. We try and use a lot of native plants and plants that just really should be here. They're going to use less water, and they're going to thrive a lot better in our climate. That makes sense, right? We do have lawns. People like their lawns, and grass isn't always going to be the most water efficient surface.
But kids love it.
Kids
dogs
love
like it.
Yep.
It's nice to picnic on.
And it's a great feature to have. So part of what we do is we use lower flow sprinkler heads, and then another thing that we do is we hydrozone things. So we kind of batch up. That's kind of fancy talk for saying that we have plants on a zone and grass on a zone, so that we can have different amounts of water going to those, so that we don't have to water them all the exact same amount.
Because a tree is going to need a different amount of water at different timing than some of the plants.
Yep.
Right?
So we can control some of the water consumption by doing that. And then also we have this rain sensor. So we get some rain here in Oregon. So we have this little rain sensor outside that will collect the rain, and once it gets to a set level, it'll cause the irrigation to go into a delay mode and not be, you won't be driving down the street while it's pouring down rain
and watching the
sprinklers go. And at some point, because it has a level before it turns off, that can happen for a while. But it's a great water savings method.
Yeah, it sounds really smart and just remarkable. Everyone isn't doing it already. And so those things were in the site options. So that's a whole nother, right, of those 5 pillars. It just seems like an incredible amount of information you must have loaded in your beautiful brain there to be able to accomplish all of this stuff. And so it sounds like you're not doing it all on your own, and you've got a lot of great resources. And from what I've heard, is Earth Advantage has been a great partner in all of this. So they're here verifying, but it sounds like maybe a little different than some of the inspections you might get from jurisdictions. They're really here to kind of help you along instead of, it's more the carrot than the whip.
Yeah, so Earth Advantage, it is a ton for all of us to keep track of. And we have a really talented team, great subcontractors that all put this together. And then we have trade partners, and then we have allies like Earth Advantage who come in and they help us with instruction, they help us with accountability, and they're just that kind of backup for us to make sure that we're getting it all right.
All right, so you've got your checklist and your Earth Advantage certification, your platinum certification, which I should also contextualize and say that to get to zero energy or zero ready certification, you first need to achieve platinum. And so you kind of work up each one of those levels, and each time you're kind of checking off in the 5 pillars, all the good things that you're doing until you achieve platinum, and then you can take the next step and get to zero energy ready. And one of the things that you do so many great things about zero ready. And so I know I'm jumping around here. We've talked a bit about the solar ready systems down in the garage, and that you've got the pre-wired car charger, and you've already energy modeled the building and to understand how much solar panels you would need if you do want to go from zero ready, which is bringing the building down dramatically in its energy consumption, right? So that you can put enough solar on the roof to offset that electrical energy use, right? And so if you, in that process, I think you take it one step further. So if I'm a homeowner buying a new home, you're not only going to tell me, hey, we're ready for solar panels because we've got these conduits in the walls and they run up to the roof, and we already know how much solar you need. We also are providing you with what else?
So we have every homeowner set up with a consultation with a solar partner of ours. We're working with Neil Kelly. So every one of our customers has the opportunity to have a consultation, an appointment with the sales people over at Neil Kelly. And they sit down with them and they show them, these are the options that we have for you. This is how much it would cost. We can show you what it means for you to have a zero energy system on your house, enough for that, or we can scale it back and you can say, I want to invest in this much. Or I guess you can go the other direction too when we have the roof space for it, and they can say, well, I have two electric cars, so can I charge my car and power my house? And a lot of our houses are actually able to offer that capability where you can cover all of your electrical needs for your house and then still charge a car for the year's worth of driving. So that partnership with Neil Kelly for us is important, not only as a service to our customer, but it helps us to plan things out better. Part of the Zero Energy Ready certification with Earth Advantage is showing an actual solar proposal. Because Earth Advantage isn't about any statements that can't be backed up or proven. That's part of the value of their certification. So to get that Zero Energy Ready standard, we have to build a really great home. It has to be up to that platinum level. And we have to then be able to show that we've done all that stuff. We have a solar proposal from a qualified solar contractor that could actually be installed on the house, no like hanging off the edges, impossible systems here, a viable solar proposal for that home to offset for Zero Energy Ready within Earth Advantage 90% or more of the annual energy consumption for the home.
That's really outstanding pre-planning, and you're really taking your sales pitch to another level too, right? I mean, it's kind of this system of accountability. And I was looking at one of your kind of flyer handouts, and you're really promoting this idea that, yeah, when we create these homes, we're going to meet these standards, and you've got Earth Advantage behind you saying, yeah, well, these are the standards, and we're going to make sure they meet them because we're going to go through the checklist with them. And you're providing that kind of whole thoughtful process so that the homeowner in the end is even getting to the level of, okay, not only do we predict your energy bills will be about this much, depending on how you drive that house, right? Similar to how fast how you get your miles per gallon, how you drive on the road. It's also how you use your energy at home. But we're going to target within that zone. You'll be 40% better than if you just bought the regular home off the market. But that's a big promise to make. And so I imagine that it takes a lot of effort to get all of your staff and employees kind of up to speed about what that means. And then there are your trade partners, your subcontractors that are doing all of this work and being thoughtful about it. How are you holding everyone accountable in this process?
Yeah, I would say a few great things happen by chance. Almost everything that's gonna be great in the world is gonna have taken a lot of planning and thought and work. So what we do is we plan everything out in advance. We think about the systems we're gonna do, what we're gonna do. We train our partners and our employees based on that. We have detailed scope of work files so that the subcontractors know exactly what they're supposed to be doing. We communicate in advance then, so there are no surprises afterwards. And then we have detailed specification sheets, and we do job walks a lot of times with people to go through and plan things out and think through how things are going to work. In addition to partnering up with our trade partners and subcontractors as we make new changes, all these things keep us rolling in the right direction.
And so those job walks, I'm imagining, is that happening just before they come in to start their work? And so you've already given them scopes of work, right? That's pretty clearly detailed. And if you just hand them those scopes of work and send them out to do their job, would everything go super smoothly?
Sometimes it might work out for you. Like some people are going to follow their checklist or go through the list on their own. But most of the time, a little extra communication and coordination, because a lot of things are coming together here. We have a number of subs. It's not like it's just one guy working slowly through the entire process. A lot of people have to communicate. So by coming together, talking things through, and then ensuring that we're checking and inspecting the work. As a builder, we do our own quality control walks and measures. That's going to make sure that we get what we say we want. Then the additional value that we have with Earth Advantage is that they're going to come in and they're going to be that extra set of eyes for us. And they're going to make sure that everything works. We train people, we learn a lot on our own, but Earth Advantage has incredible training opportunities. The Sustainable Homes Professional course is one of those opportunities, and we have sent most of our employees through it at different times.
Why would you do that?
So we can
that
talk.
That sounds expensive.
It's a great value, honestly. There is a cost, but any investment has cost. But we're seeing the return on that investment in the knowledge and the excitement that our team can bring back from that. So we can spend a lot of time out here talking about stuff. We can go through the checklists, but for them to go through this comprehensive course with excellent instruction and a great kind of curriculum, they're able to kind of see this is why we do the stuff we do, and this is why that one thing I'm working on over here actually really, really matters, or this is why this step is so important. So it reinforces what they're seeing around them. And it gives them a sense of pride in what we're doing out here. They can go, wow, we're doing a lot of really amazing stuff. And by going through this course, we not only understand why, but we can go, yeah, we do that on our house, or yeah, I'm part of that. Beyond that, we're always growing and learning. So I'm not going to stand here and talk like we have all the answers or we're doing everything that can be done. So by sending our team through these courses, they're going to bring back fresh ideas. As a final part of the course, they take a final exam and then they do a final project. So we have our team bring that final project back to us, and they present it to our team after they've presented it for passing their course.
Oh, that sounds like fun.
So that creates a lot of great natural conversation, allows them to show off what they've learned, and it gets us kind of thinking about options and things that we can do as a team.
It seems like a constant process of learning, verifying, improving, and the results speak for themselves. Great work.
Thank you.
Okay, Mike, there's so many outstanding elements to these net zero energy ready, Earth Advantage Platinum, Energy Star certified homes that are utilizing WaterSense certified fixtures and Energy Indoor Air Plus. Like, I can't even think about all this stuff. And still, you have these exceptional elements that just go above and beyond every step of the way. And here we have, I'm looking at this, and I'm thinking, this looks like it was a fully pre-cut frame. Is that true? Did you actually go as far as planning out this home that all of the framing comes pre-cut and packaged?
That's correct. You can see the builder's first source stamp on that framing there. We partner with them to use this optimized framing strategy, and all of the walls, all of the plans are taken into computer software, and they figure out how everything's going to lay out. They have these saws that operate based on that software, and they cut out the packs, they label them, and then they come out with a little book. So it's like a Lego set or something like that, where you have the instruction book and you have how it all goes together. So that saves some time on site for the framers. But the incredible thing about this is that because they're able to optimize the framing, we're cutting down on the amount of waste tremendously. When we first tried this out, we ran through and we worked with our trash hauler, Clean It Up Mark. They recycle all of our trash and take care of all that for us. And we said, we're going to do this this trial. Let's find out how much waste this is going to save, and then let's talk about if there's going to be savings on your costs and savings to us as a result. And the scrap piles were noticeably smaller. It was definitely a difference. And the framers at first, it took a little time to get used to. And the team over at Builders First Source had some learning curves to work through. But it's working really well now, to the point where if there happens to be a house where we didn't have enough time to get it planned out for the optimized pack, or it didn't get ordered early for some reason, every rare time that has happened, the framers are like, wait, where's our optimized pack? We really want that.
When it started out, everyone's scratching their head, and now it's just the simple expectation. And so that really helps translate how all of this is put together. There's a series of really extraordinary pre-planning measures, and you're getting these homes built in like 5 months, right? So again, zero energy ready homes that are Earth Advantage Platinum certified, carrying all of these other kind of sub certifications and energy performance score also coming along with it, and this very thoughtful handoff process to your owners. And all of that now seems like it's running like a pretty fluid ship. And so how do you feel about that and the work that you're doing, and what kind of value do you feel like this brings to Noyes as an organization?
So being organized and planning everything out in advance keeps us efficient. We're able to tell our subcontractors before the house even starts. The carpet guy knows when he's showing up to install carpet. Everybody throughout the whole process knows where they're supposed to be, when they're supposed to be there, what they're supposed to do. We're able then to deliver that to our homeowners in the same way. We can tell them as soon as we put the schedule together, even months before we schedule the house, we can say, this is your close date, house is going to be ready for you, and we're not going to be late. So it's a tremendous value to them, and something that people can just kind of note the reliability and the professional nature of our company. It takes a lot of people to make that happen. And we have great subcontractors. We have an amazing staff and team at our company, and all of them working together puts this house together in less than 5 months. And then a lot of that time is quality control at the end, making sure that the house is really done and ready to live in, but we're going to go through it really carefully at the end just to make sure that everything is just really dialed in.
Unbelievable. It's outstanding. I can only imagine that you must have seen this as an extraordinary challenge up front, and as you work through this in your career. Also, like, what are the big lessons learned for everyone here in this course to hear from you today?
So I think the great thing for me is there have been people before me who have been doing a lot of work to kind of put these systems together. We didn't have Sustainable Homes Professional classes when I was working on this stuff, over a decade ago, but we had a lot of great resources. So I was able to draw on the expertise of other people, and I was able to really think through how things should be done, compare it to how other people thought things should be done, and pre-plan everything. Planning is critical. So as we've worked through that, we also wanted to say, how can we pay for a lot of this stuff? And Earth Advantage, as our verifier, was able to kind of show us Energy Trust of Oregon's money savings opportunities here. So our subcontractors were able to help us work with the efficiency and costs on the systems, but then we were able to use Earth Advantage's expertise to get incentives to do things. So we're actually getting paid to do things better. That's a pretty good setup. But in that, we've worked our way through that over time. Some things cost more, some things cost less that are better. And some of those costs are then, that cost more, some of that's offset by those incentives, and some things aren't. At the end of the day, we have to look at it and say, how do we think this house should be built? What's the right thing to do? And we're going to invest in doing it the right way, even if that means sometimes it's going to cost a little bit more money.
Do you see that value translated to clients? And maybe on the back end, has there any been improvement maybe in warranty or callbacks and that sort of thing through this process?
Doing things the right way the first time always saves time and money later. And so our warranty department is one guy who does it part-time because we have low callbacks because we put the time in up front. That was the case before we were building these high-performance homes, but it has actually improved even since then. I know people talk about the percentages in dollar amounts that people set aside for warranty, and when we ran the analysis on how much warranty cost we incur on average for a house, it was ridiculously low, like almost nothing for our costs out of pocket on every house because it's done right the first time.
Oh, that's fantastic. One half-time person on a development firm pumping out 50 homes a year is spectacular.